Hello guys, so welcome to my channel. So in this video, we will be discussing about the functional interfaces. So let's get started. So what are functional interfaces? So the functional interfaces are nothing but which contains the single abstract method, and this restriction is applicable only to abstract methods only. That means a functional interfaces can contain only one abstract method, but it can contain any number of default and static methods, because in from Java 8 onwards a functional interface can contain the default and static methods. You know that, right? So I'll show you with an example. You can see there is an interface interf, and I have this public void m1 method. So this is the abstract method, and also I am including default method, that is default void m3 method, and on static method a public static void m4 method. So this is the functional interface because it contains only one abstract method, that is m1 as the abstract method. Okay, so then we have something called as authorate functional interface. So authorate functional interface is an annotation which is used on top of interface in order to specify it as a functional interface so that the compiler can validate. Okay, so let's see what is the functional interface with respect to inheritance. So I have this simple code. So what I am doing is there is an interface A, and I am annotating it with functional interface. That means it is a functional interface. And the compiler will check, yeah, public void m1. It contains only one abstract method, the single abstract method. So this is valid. So there is an interface B which extends an interface A. Okay. So this is also annotated with a functional interface. So this is also valid. Why? Because since interface B is extending from interface A, this public void m1 method will also come here. This public void m1 method will come here, so that only one abstract method present in interface B, so that we can call it as a functional interface only. So the other case is, for example, if I write public void m1 here only, then also this is valid. Why? Because if you are writing public void m1, it's kind of overriding that method. Okay, so then this is valid. And for example, if instead of m1 method, if you write m2 method, then now it becomes invalid. Why? Because this interface B is extending interface A. This public void m1 method will be inherited to interface B, and also it has m2 method. That means it contains two abstract methods. So that's why it is invalid. So if you want to make it valid, you just remove this functional interface annotation. Then the compiler will treat it as a normal interface rather than it is a functional interface. So I think you got the differences. What is the use of functional interface annotation and how we will use it. And also I can make a conclusion from out of this, that if the parent is functional interface, then child is also the functional interface till it does not contain any methods. Now in our case, interface A and interface B, A is the parent and B is the child. Since B does not contain any methods, I can say B is also functional interface. So now let's look at Lambda expressions with functional interfaces. So this is going to be a fun video, fun concept. Let's see. So I have an interface interf. So first concentrate on the left side. I have an interface interf, and it has one abstract method, that is public void m1 method. And I am giving implementation for that abstract method. What I am doing, class demo, I am implementing interf, and I am giving implementation for this m1 method. You can see this is the implementation. And I have a test method which has the main method, that is public static void main. And if I want to call this m1 method, means what I am doing is interface I is equal to new demo. So why? Because this interface parent reference can be used to hold child object. Okay, that is interface reference can be used to hold implementation class object. That concept you know, right? So that's why I am using interface I is equal to new demo. And if you want to call that method I dot m1 method, I'll call, so that you will get SOP of hello, that is hello as the output. So you can see first I have an interface, I am then implementing that interface, then in that main method I am calling that interface with that implementation class. So this is a lot of code. So how we can improve that with the help of lambda expression? So let's look at the code in the right side. So we have the same interface, we have public void m1 method. So instead of writing this method class demo implements interrupt, we will be removing completely. Since it is an functional interface, what I am doing is class test, then this main method public static void main string arrays. I am using interrupt I is equal to this lambda expressions. This public void m1 method, I can write it as just parenthesis, because lambda expression does not have a return type, modifier and name. Lambda expression and the implementation, and I'm giving it as sop of hello. And if I want to call that method, I just call I dot m1 method. So that's it. That is done. You no need to have a separate method that is implementing that interface. So with the help of this lambda expression and functional interface, you can make the code in a concise way. And I am using this functional interface I as a reference variable, right? So that functional interface can be used to act as a reference for your lambda expression. So you can see this line. So that's why I'm using this functional interface as a reference for your lambda expression. And you will be confused, like how compiler will map. You are writing, see, in the test method you are writing just the parenthesis, right? How compiler will map this parenthesis to the m1 method? So that may be your question. So my answer to this is, see, this interface is known as is a functional interface. That means it contains a single abstract method. So since it contains a single abstract method, the compiler will automatically map this parenthesis to the m1 method only, because it has only one method, so it will map to that method only. So when I call I.m1 method, so this the implementation we have given with the help of lambda expression, that will be get executed. You got it, right? So that is how I have written, like how compiler will map that parenthesis to m1 method. So this is all about functional interfaces and how we can use functional lambda expressions inside functional interfaces in order to invoke it. So I think that's all for this video. If you have any doubts, please write it in the comment section, and thank you so much for watching.